In the silent, interwoven tapestry of the cosmos, there are rivers of light. Not rivers of water, but of galaxies, flowing through the void, drawn by an unseen current. We reside within one such river, a filament of the Laniakea supercluster, a structure so vast that light itself takes 500 million years to cross it. Our own Milky Way is but a single drop in this celestial ocean, pulled inexorably toward a gravitational anomaly known as the Great Attractor, a destination we can see but not yet comprehend. If we were to follow these cosmic currents, to drift downstream through this river of star islands, we would eventually arrive at one of its most densely populated regions, a sprawling, ancient metropolis of galaxies. This is the Abell 85 cluster, a gravitational well 700 million light-years from Earth, where hundreds of galaxies are locked in a slow, cosmic dance of death and birth. At its very heart, enthroned in the deepest part of the gravity well, sits a king. A colossal galaxy, a behemoth known as Holmberg 15A. It is a giant among giants, a diffuse, ghostly sphere of stars more than 15 times the width of our own Milky Way. But as our gaze pierces its ancient, reddish glow, we find something profoundly wrong. Something is missing. At the very center of this galactic titan, where the starlight should be at its most brilliant, its most concentrated, there is a void. A core of incomprehensible size, hollowed out, unnaturally dark and empty. It is a wound in the heart of a galaxy, a silent testament to an event of unimaginable violence. What power, what entity, could be so great as to scour the very center of a galaxy clean, casting its stars out into the darkness? What kind of monster builds its lair not from rock or shadow, but from the empty space where a trillion suns ought to be? To understand this ghost at the heart of the universe, we must journey into the darkness it has created, and confront the architect of this profound and terrifying silence. Now, let's begin. Music. The realm of Abell 85 is not a tranquil star field, it is a battlefield, shaped by the most fundamental and relentless force in the universe, gravity. Here, in this cosmic crucible, galaxies are not isolated islands of light but active participants in a gravitational war that has raged for billions of years. Imagine a city, not of buildings and streets, but of star systems and nebulae, all caught in a slow-motion collapse toward a common center. Each galaxy, with its hundreds of billions of stars, its own central supermassive black hole, its own history, is a soldier in this war. The space between them is not empty but filled with a superheated, X-ray-emitting gas, the captured atmosphere of countless galaxies that have been stripped bare as they fall inward. This is the intracluster medium, the spectral evidence of past skirmishes, the ghosts of galaxies torn asunder. Gravity, here, is not a gentle guide holding planets in orbit, it is a tyrant. It dictates the flow of matter, the speed of collisions, and the ultimate fate of every star and every world within its domain. The smaller galaxies, the dwarf and spiral systems, are the first to fall. As they plunge toward the dense core of the cluster, they are subjected to a process of cosmic torment. Tidal forces, the differential pull of gravity across their structures, stretch them into long, ethereal streamers of stars, like paint being dragged across a black canvas. Their gas is stripped away by the pressure of the hot entrustor medium in a process called ram pressure stripping, leaving them anemic and unable to form new stars. They become red and dead, their vibrant blue youth extinguished, their futures stolen. They are the casualties, the forgotten footnotes in the cluster's violent history. At the center of this gravitational vortex, where the density of galaxies is highest, the nature of the conflict changes. It is no longer a war of attrition, but one of outright cannibalism. Here, giant elliptical galaxies, themselves the product of previous mergers, engage in a final, majestic dance of consumption. They orbit one another, their vast stellar halos overlapping, their gravitational fields wrestling for dominance. Over millions of years, they merge, their stars intermingling, their central black holes spiraling toward one another in a union that shakes the very fabric of space-time. This is the law of the cluster: to grow, one must consume. And in Abell 85, one galaxy has consumed more than any other. Holmberg 15A sits at the precise barycenter, the gravitational heart of the entire cluster. It did not drift here by chance. It is here because it is the most massive, the victor of this eons-long war of cosmic attrition. It is a brightest cluster galaxy, or BCG, a title reserved for the kings of these galactic kingdoms. Its immense, bloated form is not the mark of a healthy, star-forming system, but the scar tissue of 1,000 violent unions. Every star in its vast, diffuse halo may have once belonged to another galaxy, another life, now assimilated into this single, monolithic entity. It is the ultimate predator in this ecosystem, a quiet giant resting after a feast that has lasted for 10 billion years. Its stillness is deceptive, for it is the stillness of absolute dominance. It is the gravitational anchor for the entire structure, the sun around which hundreds of other galaxies now orbit as mere planets. Its story is the story of Able 85, a history written not in ink, but in the orbits of captured stars and the light of devoured worlds. To gaze upon Holmberg 15A is to witness the end state of galactic evolution. It bears no resemblance to the graceful, pinwheeling spirals of galaxies like our own Milky Way or Andromeda. There are no elegant arms traced by the light of young, blue stars. There are no vibrant pink nebulae, the stellar nurseries where new suns are born. All of that has been erased, consumed, and homogenized into a single, featureless glow. It is an elliptical galaxy, but one of a truly extreme nature. Its shape is a distended, triaxial spheroid, a cosmic football of ancient light. The vast majority of its stars are old, red, and dying, having formed billions of years ago in the galaxies that Holmberg 15A later absorbed. This sea of ruddy light gives the galaxy a ghostly, ethereal appearance, as if it were an apparition from a long-dead universe. Its light is faint but its influence is absolute. Spanning over 1 million light-years from one edge of its stellar halo to the other, it is a diffuse giant, its outer regions fading so gently into the intergalactic medium that it is difficult to say where the galaxy truly ends and the void begins. This extended halo is a graveyard. It is composed of stars that were not born within this galaxy but were captured, torn from their parent systems during countless mergers. These are the tidal streams, the faint, arcing structures that wrap around the galaxy like silken threads, each one a relic of a devoured spiral or a consumed dwarf. They are the architectural ghosts of the galaxies that were sacrificed to build this monument to gravity. This galaxy is, in a very real sense, sleeping. Its rate of star formation is virtually zero. The raw materials, the vast clouds of cold hydrogen gas needed to ignite new suns, were exhausted long ago or were heated to such extreme temperatures during mergers that they could no longer collapse. It is a quiescent giant, a galaxy in its cosmic retirement. But this serene image of a sleeping elder is a profound deception. Its placid exterior hides a history of unparalleled violence, and its calm belies the presence of a central engine whose power defies easy comprehension. The very structure of Holmberg 15A is a paradox. It is simultaneously one of the most massive galaxies known, yet also one of the most diffuse at its center. Its light profile does not follow the expected pattern. In a typical giant elliptical, the density of stars increases exponentially toward the center, creating a brilliant, star-saturated core, a blinding cusp of light. But as we approach the heart of Holmberg 15A, the opposite happens. The light fades. The density of stars plummets. It is as if the very heart of the galaxy has been scooped out, leaving a cavity of stunning proportions. This is not the gentle dimming of old age. This is evidence of an active, architectural force that has fundamentally reshaped the galaxy from the inside out. The quiet, sleeping giant is a facade, concealing a throne room that has been violently emptied. The king may be resting, but the evidence of its terrifying power is etched into the very structure of its kingdom. The core of Holmberg 15A is the scene of a cosmic crime. It is a region of space so dark, so empty, it fundamentally challenges our understanding of how galaxies are built. This is the central mystery, the hollow heart of the giant. The void spans a staggering 3,000 to 5,000 light-years across. To put this into perspective, the distance from our Sun to the supermassive black hole at the center of our own Milky Way is 26,000 light-years. The empty core of Holmberg 15A is a chasm so wide that thousands of star systems like our own could fit within it, side by side. In this region, where astronomers expected to find a dense cluster of 1 billion stars packed into a few cubic light-years, they found a stellar desert. The surface brightness, a measure of the amount of light emitted per unit of area, drops to a level that is almost unthinkably low for the center of a galaxy of this magnitude. It is a core-less galaxy. This is not a subtle anomaly detectable only through complex statistical analysis. It is a glaring, obvious emptiness, visible as a plateau of darkness in the galaxy's light profile. Imagine a mountain that, instead of rising to a peak, simply flattens into a vast, high-altitude desert. That is the heart of Holmberg 15A. What could do this? The usual suspects in cosmic evolution do not fit the profile. The slow, methodical process of stellar aging and death would not create such a sharp, well-defined boundary of emptiness. The explosive death of stars in supernovae, while violent, is a localized event, incapable of clearing a region thousands of light-years across. This was not a gradual erosion, this was an excavation. This was a deliberate act of gravitational engineering on a scale that borders on the mythological. It is a wound, a hollow space where the heart should be. It is a silent scream, spoken in the language of missing light, echoing across 700 million years. The emptiness itself becomes a clue, a negative image that points to the presence of the culprit. Something with enough gravitational authority to tell a billion stars where they are not allowed to be. The investigation into this void forces us to consider processes of extreme violence, events so powerful they can rewrite the fundamental structure of a galaxy. The emptiness is not an absence of matter, but the presence of a verdict, handed down by a power that has judged this region and found it wanting of stars. It is the ultimate display of territorial dominance, a warning sign carved into the fabric of the galaxy itself. The question is no longer if something monstrous resides here, but to understand the mechanism by which it cleared its domain so completely, and so terrifyingly. The hollow core is a fingerprint, and it belongs to a giant. The first plausible explanation for this extraordinary emptiness does not involve a single object, but two. This is the binary scouring hypothesis, a theory that paints a picture of a gravitational dance of unimaginable scale and violence. The story begins with a merger, not of stars, but of galaxies. Billions of years ago, the galaxy that would become Holmberg 15A collided with another massive galaxy. As the two star systems coalesced, their central supermassive black holes, each with a mass of billions of suns, began a slow, inexorable spiral toward their shared new center. They were now bound in a binary system, two gravitational titans waltzing in the heart of their newly formed galactic home. Their dance was not elegant. It was a chaotic and destructive ballet that would forever alter the core of the galaxy. As these two black holes orbited each other, they became a gravitational slingshot of cosmic proportions. Any star that was unfortunate enough to wander into their path, to pass too close to their deadly dance floor, was subjected to a three-body interaction. The star, interacting with the immense gravitational fields of the two spiraling black holes, would be violently accelerated. Like a stone flung from a slingshot, the star would be ejected from the galactic core at tremendous speed, often fast enough to escape the galaxy's gravitational pull entirely, cast out into the lonely darkness of intergalactic space. This process, known as the gravitational slingshot effect, is ruthlessly efficient. Over millions of years, as the binary black holes continued their spiral, they would systematically clear out their orbital region. Star after star, system after system, would be flung away. They were not consumed by the black holes, they were exiled. The core was not eaten, it was depopulated. The binary black holes were acting as gravitational housekeepers, tidying their new home by throwing out all the stellar furniture. This hypothesis beautifully explains the observed emptiness. It accounts for the vast size of the core, which would correspond to the orbital domain of the binary system. It explains the sharp edges of the void, the boundary beyond which the slingshot effect was no longer dominant. And it explains the low density of stars, they were simply no longer there. Eventually, the binary black holes would lose enough orbital energy, primarily through these stellar ejections and the emission of powerful gravitational waves, that they would finally merge. This final cataclysmic event would create a single, more massive black hole, releasing a burst of energy equivalent to trillions of supernovae and sending ripples through the fabric of space-time. The new, unified black hole would then sit alone in the center of the vast, silent void it had helped to create. The hollow core, therefore, is a fossil. It is the remnant of a dance between two monsters, a scar left behind by a gravitational war that took place in the galaxy's distant past. The missing stars are the silent witnesses, now scattered across the cosmos, to the power of a binary titan. This elegant and violent theory became the leading candidate for the mystery of Holmberg 15A. The only remaining task was to find the evidence, to search for the signature of the single, colossal object left behind. To confirm the binary scouring hypothesis and measure the mass of the beast at the center, astronomers needed to look for its gravitational influence on the stars that remained. They could not see the black hole itself, for it emits no light. They could only infer its presence by watching its effect on the things around it. They turned the unblinking eye of the European Southern Observatory's Very Large Telescope, VLT, in Chile toward Holmberg 15A. Using a sophisticated instrument called the Multi-Unit Spectroscopic Explorer, or MUSE, they began a painstaking process of cosmic archaeology. MUSE is a remarkable device. It doesn't just take a picture, it takes thousands of spectra simultaneously, one for every point in its field of view. This allows astronomers to create a detailed 3D map of a celestial object. For each point in the galaxy, they could measure not just its brightness, but its chemical composition and, most crucially, its velocity along our line of sight, determined by the Doppler shift of its light. Their target was the edge of the void. They focused on the stars orbiting just at the boundary of the hollowed-out core. These were the innermost surviving stars, the ones that had been spared the fate of their exiled brethren. Their orbits held the key. According to the laws of gravity, the speed at which these stars orbit the galactic center is directly related to the amount of mass contained within their orbit. By measuring the velocities of these sentinel stars, astronomers could effectively weigh the unseen object at the heart of the void. What they found was staggering. The stars at the edge of the core were moving at incredible speeds, whipping around a center that was visibly empty. Their frantic, high-velocity orbits were a dead giveaway. They were leashed to an object of truly immense gravitational power. The data poured in, and the calculations began. The team constructed complex dynamical models, simulating the orbits of millions of stars under the influence of a central mass, and then compared these models to the actual observations from MUSE. They were reverse engineering the monster, using the motions of its celestial prisoners to deduce the nature of their jailer. The initial estimates were so large they were almost unbelievable. This was not a black hole of a few billion solar masses, as would be typical for a large galaxy. The numbers kept climbing. The models that best fit the observed stellar velocities required a central object of unprecedented mass. The evidence was undeniable. The emptiness of the core was not the only clue, the frenetic motion of the stars at its edge was the corroborating testimony. They were orbiting something so massive it was warping spacetime in a way that had rarely been witnessed before. The scale of the object was beginning to come into focus, and it was far larger, far more extreme, than even the binary scouring hypothesis had initially suggested. The ghost in the heart of Holmberg 15A was about to be given a name and a number, a quantity of mass so vast it would secure its place in the annals of cosmic record breakers. The result of the meticulous analysis was a number that sent shockwaves through the astronomical community. The object at the center of Holmberg 15A, the architect of the Great Void, was a single, ultramassive black hole with a mass calculated to be 40 billion times that of our Sun. Let that number settle. Not 40 million. 40 billion. Designated Holmberg 15A, it was, at the time of its measurement, the most massive black hole ever discovered through the direct observation of stellar motions. It is a true leviathan of the cosmos. To comprehend this scale, consider Sagittarius A, the supermassive black hole at the center of our own Milky Way. It is a formidable object, weighing in at a respectable 4 million solar masses. Holmberg 15A is 10,000 times more massive. It is not just in a different league, it is playing an entirely different game. The entire Andromeda galaxy, our largest neighbor, could be fed to this black hole, and it would be but a modest snack. The physical size of this object is as mind-bending as its mass. The event horizon of a black hole, its point of no return, is defined by its Schwarzschild radius. For Holmberg 15A, this radius is estimated to be around 236 billion kilometers. This means the diameter of the black hole's shadow is nearly 500 billion kilometers. Our entire solar system, out to the orbit of Neptune, is about 9 billion kilometers across. Holmberg 15A could swallow our solar system, and all the planets, whole. The Voyager 1 spacecraft, the most distant human-made object, traveling for over 4 decades, would take more than 1,000 years just to cross the diameter of this black hole's event horizon. It is a region of spacetime so vast and so warped that it ceases to be a point and becomes a place, a destination from which there is no escape. This is the monster. The culprit. The final answer to the mystery of the hollow core. The binary scouring hypothesis was correct in its mechanism, but the sheer scale of the resulting object exceeded all expectations. It was the product of not just one, but likely multiple mergers of massive galaxies and their central black holes over cosmic time. Each merger added to its mass and helped to clear out the core, ejecting stars in a repeating cycle of consumption and expulsion. The 40 billion solar mass measurement is the direct consequence of this long and violent history. It is the gravitational king, sitting on a throne of empty space, ruling over a kingdom it has shaped through sheer force. The void is its shadow, cast not by blocking light, but by its fundamental rewriting of the laws of motion in its vicinity. It is a perfect predator, having created a perfectly empty domain for itself. The silence at the heart of Holmberg 15A is the sound of 40 billion suns collapsing into a single point, a symphony of gravity played in a key of absolute darkness. To understand the existence of an object like Holmberg 15A, we must look back in time, to the dawn of the Abell 85 cluster. This black hole was not born this massive. It grew. Its history is a chronicle of cosmic violence, a story of relentless consumption written in the language of gravitational mergers. In the early universe, galaxies were smaller. The primordial seeds of today's giants were modest collections of stars and gas, each with its own central black hole, likely only a few thousand or million times the mass of the Sun. As the universe expanded and cooled, gravity began to pull these early structures together. In the dense environment that would become Abell 85, these mergers were frequent and transformative. The protogalaxy that would one day be Holmberg 15A began its life as one of many, but it had a crucial advantage: location. It formed near the center of the nascent cluster's gravitational well, making it a natural focal point for infalling material. Its first major meal was likely another galaxy of comparable size. As the two systems collided, their stars intermingled, but their central black holes embarked on a more intimate journey. They sank toward the center of the newly merged galaxy, forming the fateful binary pair. For millions of years, they danced their destructive waltz, flinging stars out of the core and radiating gravitational waves. Finally, they coalesced, creating a single, more massive black hole, now sitting in a partially cleared-out core. But the feast was not over. As the dominant galaxy at the cluster's center, it continued to pull in other, smaller galaxies. This was not a single event, but a continuous process, a steady rain of galactic prey. Each time a significant galaxy was consumed, it brought with it its own central black hole. A new binary would form, a new dance would begin, and the core would be scoured anew. The central black hole grew in a series of punctuated equilibria, long periods of quiet feeding on gas, punctuated by dramatic, violent mergers with other black holes. Each merger added billions of solar masses to its total and reinforced the emptiness of the core. The void we see today is not the result of a single event, but the cumulative effect of a dozen or more such mergers over 10 billion years. The core of Holmberg 15A is an archaeological site. Its immense, low-density structure is a fossil record of the black hole's growth. It is the layered, overlapping evidence of multiple generations of binary scouring events. The black hole's mass is the sum of all the black holes it has consumed, and the core's emptiness is the sum of all the stars they have collectively exiled. This process is the ultimate expression of hierarchical structure formation, the central paradigm of modern cosmology. Small things form first, and then merge to create larger and larger things. Holmberg 15A and its central monster are the logical, terrifying endpoint of this process in one of the densest regions of the universe. It is a living testament to the idea that in a universe governed by gravity, the rich always get richer, and the biggest predator eventually eats everyone else. Today, the great beast sleeps. The heart of Holmberg 15A is a realm of profound and unsettling quiet. The long, violent campaign of growth and scouring is over, at least for now. The central black hole, Holmberg 15A, sits in a state of near-total dormancy, a sated predator resting in the silence of its own creation. Its immediate food source is gone. The dense cusp of stars that would normally crowd the center of a galaxy, providing a steady stream of fuel in the form of stellar winds or tidally disrupted stars, has been systematically ejected. The core is a desert, and the oasis has run dry. This is why the center of Holmberg 15A does not blaze with the light of a quasar. A quasar is the signature of a rapidly feeding supermassive black hole, its accretion disk heated to billions of degrees as it consumes matter at a furious rate. But Holmberg 15A has nothing left to accrete in large quantities. It has, in a sense, starved itself by being too efficient at clearing its territory. And so, it is quiet. But this is not the gentle, peaceful quiet of slumber. It is the heavy, oppressive silence of absolute power. The black hole's gravitational influence is as strong as ever. It continues to hold the galaxy together, its immense mass dictating the orbits of stars hundreds of thousands of light-years away. Its silence is not a sign of weakness, but of ultimate victory. It is the quiet of a king on a throne, with no challengers left to face. However, it is not perfectly dormant. Even in this barren void, a trickle of sustenance remains. The vast volume of the galaxy is still filled with a thin, hot interstellar gas. Occasionally, a filament of this gas will lose momentum and begin a long, slow spiral inward, a final offering to the sleeping god. As this gas approaches the event horizon, it forms a faint, ghostly accretion disk. It does not shine with the brilliance of a quasar, but with a low, spectral whisper of X-rays and radio waves. This is the faint breath of the sleeping giant, the last ember of a once raging fire. This state of quiescence is the destiny of most brightest cluster galaxies. After an adolescence of chaotic mergers and a maturity of violent growth, they enter a long, quiet old age. The central engine, having consumed all that is within its immediate reach, powers down. The galaxy drifts, a ghost ship on a cosmic ocean, its past violence forgotten by all but the silent void at its heart. But time in the cosmos is long. The Abell 85 cluster is still a dynamic environment. In a few billion years, another large galaxy may spiral into the core, drawn by the irresistible pull of Holmberg 15A. A new merger will begin. A new binary will form. And the sleeping giant will awaken once more, its hunger renewed, ready to begin the cycle of scouring and consumption all over again. The silence is only temporary. The monster is not dead, merely waiting. We have journeyed across the cosmic ocean, from the familiar shores of our own galactic neighborhood to a distant, ancient city of stars. We navigated its gravitational currents, past the ghosts of shattered galaxies, to arrive at the throne room of its king, Holmberg 15A. There, we confronted a profound mystery, a heart of darkness, a void where a brilliant core should have been. The solution, we discovered, was as magnificent as it was terrifying. The emptiness was not an absence, but a presence, the unmistakable signature of a 40-billion solar mass black hole, one of the largest ever found. This ultramassive object, the product of a long and violent history of galactic cannibalism, did not eat the stars at its center. Instead, through the chaotic dance of binary black hole mergers, it acted as a gravitational slingshot, flinging a trillion suns out of its domain, exiling them to the void. The hollow core is its masterpiece, a kingdom of empty space carved from the heart of a galaxy. We have seen that galaxies are not static, jeweled islands in the night. They are living, breathing, evolving entities, locked in a constant struggle for survival, governed by the relentless hand of gravity. And at their hearts, black holes are not mere points of destruction. They are the engines of galactic evolution, the sculptors of cosmic structure, the architects of both fullness and emptiness. The void in Holmberg 15A is a testament to this truth. It is the physical manifestation of a black hole's power to shape its environment on the grandest of scales. It teaches us that the most extreme objects in the universe leave behind the most extreme evidence, and that sometimes, the most important discoveries are made by observing what is not there. As we pull our gaze back from this distant giant, the the silence of its core echoes in our own understanding. It is a profound reminder of the cycles of creation and destruction that define our universe, a universe where even light must kneel to the authority of darkness, and where the heart of a galaxy can be sacrificed to feed the hunger of the singularity it contains. What would you have done if you could have witnessed it over the eons? The slow, majestic merger of galaxies, the violent dance of binary titans, the final, silent reign of the monster in its empty court. Would you see an agent of pure destruction, a cosmic horror devouring all light and life? Or would you see the face of creation itself, a fundamental force of nature building the largest structures in the universe through a process of unimaginable power and awesome, terrible beauty?